Shane, and today in Homemade Science I want to go back and revisit the high road, low road track. Now, I did a previous video on this and I had so many questions and comments I thought it would be worthwhile to go back and do a few more demonstrations on it and take a closer look. Now, this is a classic physics problem where we have two tracks that start at the same position and end at the same position, but their path from one side to the other is completely different. Now, these balls are able to roll down the tracks, so the question is, if I were to release them simultaneously, which track would get the ball to the opposite side the quickest? Well, let's give it a try. So the shortest distance between 2 points is not necessarily the fastest. Now, what's going on here? Well, we're giving both balls potential energy by lifting them up to a certain position. When I release them, only a small amount of its potential energy is changed into kinetic on this track, so its speed across the track isn't very high. However, on the low road track, I started out at that high position. It drops down, changes that potential energy into kinetic, but then it drops an additional distance, so more potential energy is changed to kinetic, so it's going to cover this distance at a higher speed. Now, I've always enjoyed these tracks, so I thought it would be fun to try some variations in it, so I've made other ones, and in this case, I've added a single hill in the center of the low track, which comes back up to the original height of the high road track. Now let's give this one a try. Let's try it with two humps. A little bit more complex. Let's see what happens with this one. So once again, the same results. Let's try one even more complex. In this case, I have a track that's got three humps in the center. They're coming up to the same height as the original high road track. Let's try this one. So adding more hills wasn't enough to even out the race. So another possibility would simply to give it a bigger drop on the low side. So let's get rid of this track and try it with one that's going to drop quite a bit lower. Now let's give this one a try and see what happens. Giving the track a bigger drop simply changed more of its potential energy into kinetic energy, which means it had a higher horizontal speed, and that's getting it over to the other side even faster. Does it matter which side we drop it from? Doesn't look like it. Now, another popular question I received actually had to do with the track itself. While I'm saying from here over to here is the same distance, the actual track, because it's dropping to a lower level, obviously this track must be longer. But by how much? Well, let's take a look. The high road track is 89 centimeters long, and the low road track is 92 centimeters long. The track with the biggest drop, our high road, has a length of 134 centimeters, while the big drop has a length of 143 centimeters. (121, 127). Not much of a difference. Now, another popular question I had was, if I release the ball simultaneously, which track would the ball stop on first? So let's give that a try. The ball on the high road is stopped, but the ball on the low road will continue to move back and forth for about 1 more minute. Now let's try the same test again with this one. Once again, I'll release them simultaneously, and we'll see which one stops first. Now we could try this with the other tracks and we'd still find the same results. The track that lowers the ball to a lower level is simply changing more of its potential energy into kinetic, so it's going to take a longer amount of time to get rid of that extra energy through friction. Now another question asks, is there a limit to how low this track could drop and still have the ball reach the opposite side before the ball on the high road track? And the answer is yes, and it has to do with the type of energies we're changing it into. We're changing from gravitational potential energy into 2 types of kinetic energy. The translational kinetic energy is due to the object moving forward. Rotational kinetic energy is energy that an object has due to its turning around its axis. When an object is round, it's friction that causes it to turn as it moves across a surface. So these balls have a combination of translational and rotational kinetic energy as they move across the track. Now for the ball to climb the opposite side, it's got to change those kinetic energies back into gravitational potential energy. And if I try making this track too low, well then the sides would become steeper. And if it's too steep, then we're not going to have enough friction between the ball and the track to be able to change that kinetic rotational energy back into gravitational energy to climb the track. Now I polished this track with some car wax, and I also got a brand new steel ball here and I put an X on it and polished this one. So I think we can see that slipping right about here if I try this one. The steepness of the track is going to be the limiting factor on how far that track can be dropped. If the track is too steep, the ball slips and it can't recover that rotational kinetic energy. So it's friction that's causing both balls to change their gravitational potential energy into rotational kinetic energy and back again as they move back and forth across the tracks. Now the friction is also causing both balls to slow down, but a popular question has been, which track has more friction? Well, that's something we can test a little bit easier on another track, so let me switch tracks here. Now there's a couple ways that we can actually test this. The first way would simply be to release the balls and examine which ball gets to a higher level over on the opposite side. So if we examine our results closely, we'll see that the high road track lifts the ball to a higher level on the opposite side than the multiple hill low road track, which means that it must be losing more of its original potential energy that I gave it at the very start. And it's losing that energy to friction. Well, it looks like if we throw enough hills in there, that eventually we're going to overcome that increase in kinetic energy and give the high road track a chance to not only catch up to it, but to surpass it. Now I do have one more track we want to take a look at, and that has to do with the material itself. So let me go get that. Now I just wanted to show this track because I've had quite a few questions asking about the track material. It's simply made out of shelf bracket tracking. It's available at hardware stores, and this track I made in about 5 minutes. So the tracks don't necessarily have to be as complex as mine, and you don't need steel balls. In this case, we can just try it with golf balls. Let's give this one a try real quick. Well, there it is. It doesn't get much simpler than this. Now, in a future video, I am going to address just how easy it is to make your own tracks out of this material, so hopefully you can try some of these experiments for yourself. Now, I hope that this video has addressed some of the questions and comments that I had concerning the high road, low road tracks, and if you have other questions, please put them in the comments below. Okay, thanks for watching. Bye!